We're going to look at the area of some parallelograms and some triangles. So first we're going to talk about parallelograms. And what parallelograms are just sort of rectangles that are leaning on their side. So we draw them, and they're called parallelograms because these two lines are parallel and these two lines are parallel. So their lengths are parallel to each other and their widths are parallel to each other, and that's how they get their name, parallelograms. Well, the area, to find the area of a parallelogram, the formula for that is the base times the height, or the length times the width. Now here we do have a little bit of an issue because this line right here, that is not the height of one. So remember, this is going to be our base, so we'll call that the B, but the height of these is actually what makes this 90-degree angle right here. So this is actually your height in here. Now some people, you can also make that a straight line here and bring it out like that to create that 90-degree angle. This could also be your height here, or same thing on the other side. You could bring those out. So that's the thing to remember on these parallelograms, is that slanted line is not actually a true height length, that you want to make sure that height is always what we would call a perpendicular line to that base, which is what creates that 90-degree angle to that base. So that's what we're always going to be looking for. All right, well, let's go do a couple of these. I think most of your problems here are going to always be labeled for you. Okay, so here's a parallelogram. Let's say it's got 6 centimeters down here. This might be drawn for us already, and it should be. Creates that 90-degree angle. Let's say that's 2.9 centimeters. So you know that that's going to be that height, is that line, that straight line there. Okay, so the area is base times height. So area is base, which is 6, times height, which is 2.9. So the area of this parallelogram is 17.4 centimeters squared. Okay, let's try one more. And this might be one where this line is drawn on the outside of it, which is totally fine. We'll say that one is 11 inches. Let's say this is 6 inches. And as long as those are dotted lines, which I didn't do great of a job making dotted lines, you know that that's not part of the figure, that those are just showing you those lines brought out. All right, so the area of that would be 6 times the 11. So the area here is 66 inches squared. All right, that's about all there is for parallelograms. Let's go do a couple of triangles. Okay, so now we're going to move into something that's got a little bit of a different formula. So the area of a triangle is actually 1/2 the base times the height. Well, let's think about that for a little bit. We already know a rectangle, right, is the area of that is base times height. And so think about, if we create a triangle, really, we can create a perfect triangle by drawing a diagonal through a rectangle. So that's where we get the area of one triangle is 1/2 base times height. So you see how it's half of a rectangle is a triangle. So that's pretty cool. So let's just do a couple of those. You just have to make sure that you get that half in there. Some people, you might see it also written as base times height divided by 2. Sometimes that formula is a little bit easier to use. So either one works. So let's say this is 5 inches, this is 12 inches, this is 13 inches. Okay, so you might have an entire triangle that's all labeled. We need to remember what's the base and what's the height. Remember, on a triangle, any kind of a triangle, this is going to be your base. Remember, the height has to create that 90-degree angle there. This is your hypotenuse. Remember, and any of those slant lines do not give us a true length of the base or the height of it. So you always want to make sure it's the base times the height, then divided by 2. So the area of this would be 12 times 5 divided by 2. Well, 12 times 5 is 60 divided by 2, which is 30 inches squared. Area is always written as squared units. All right, let's try another one that's just not a perfect little beautiful triangle like the one I drew before. What if you have like an obtuse triangle here, and you're told this one is, 14 centimeters, so this does not give us the true height of it here. Remember, it's not creating that perfect perpendicular line that's creating a 90-degree angle. So they may be giving you this little information out here, drawing those lines on out, giving you that 90 degrees and telling you that is then 5 centimeters. Okay, so you may see something that looks like that. And so this would be then your height over here. And this is still your base. They're telling you that base is actually that, length from here to here. Okay, so the area of this one would be 14 times 5. And if you, we can say divided by 2, or remember, you can say 1/2, then that 14 times 5. Remember, if you're using a calculator on that, 1/2 is 0.5. So you want to, can use that. But base times height divided by 2 is really sometimes just your easier one. So that's 70 divided by 2. So the area there is 35 squared centimeters. So that's pretty easy.